we're going to talk about 3.1, which is solve system of equations by graphing. Okay, so we're going to graph the equation and find the solution from the graph. Okay, the first example over here is this system of two equations. Both of them are linear. Okay, how do we find the solution? Okay, so the first step here is to graph both equations. Okay. Okay, so we're going to graph both equations. So graph the first one. Okay, it will be easier if we put the equation in slope-intercept form, so we can use the y-intercept and slope to graph it. So to put that in y equal to mx plus b form, remember the slope-intercept form. Okay. So if we can put this in the slope-intercept form, we can use the y-intercept and also the slope to graph it. Okay, it's easier. Okay, so I'm going to isolate the y, isolate this y, and put that in this slope-intercept form. So to isolate y over here, we first isolate 2y, so we subtract x from both sides. So over here, what do we get? So we get 2y equal to
4 minus x.
Yeah, 4 minus x or negative x plus 4. Okay. Now, to isolate the y, we need to undo this multiplication with 2. So we will divide both sides of the equation by 2. That way, this side here will end up with y. On the other side, we have negative 1 over 2 times x. So we'll have negative 1 half times x. And then plus, see, this is negative 1 over 2. Okay, there's an invisible 1 here. So it's negative 1 over 2, and then times x. You can put the x here on the side or in the numerator on top. These two are equivalent. Okay. Now, 4 divided by 2 will be 2, so adding 2. Okay. Now you see that this is the y-intercept, and this is the slope. You can write this as negative 1 over 2, okay? Or you can write it as 1 over negative 2. If I put it this way, then negative 1 will be the rise. And the corresponding run here will be positive 2. If I put it this way, then positive 1 it will be the rise. And then this negative 2 will be the corresponding run. Okay, both are okay. Okay. Similarly, we're going to isolate the y here for the second equation. So we'll have the way we do it. I can actually move this negative y over to the other side and become positive y. Okay, and then I move this 3 over to this side and become negative 3. So I have y equal to 2x minus 3. So the 2 here is the slope. Okay, you can think about it as 2 over 1. And so think about the 2 here as a rise, and
the run here is 1.
The y-intercept over here is this negative 3. Okay. Now I put both equations over here in this slope-intercept form. Now I'm ready to graph both of them. Okay. Let's graph the first one, this one over here. The y-intercept is positive 2. So on the y-axis, we're going to locate 2, which is this point right there. So locate the y-intercept point 2 here on this y-axis. Okay. And then use the slope, which is, let's use the first one here, negative 1 over 2. So from the y-intercept point, I'm going to go down 1 unit and then move to the right 2 units to get another point, right? So I'm going to end up at this point over here. So down 1 to the right side, 2, got this point. And then I can get a straight line that goes through them. Okay. Okay, so that's the straight line. This is for the first equation. Okay, I label that 1. Okay, now the second equation, okay, is this. The y-intercept here is -3, so I locate -3 on this y-axis. So it's this point over here. And then the rise over here will be 2, and the corresponding one is 1. So from the y-intercept point, I'm going to go up 2, run to the right side 1, I get this point. You can actually continue doing this. And then we go up 2 to the right 1 to get another point. Okay. So up 2 to the right 1, you get 1 point. And then continue this way, up 2, right 1, you get this point. Now you graph it. Okay. Okay. So I label this number 2. Okay. So that's the graph for the second equation. Now, after you graph these two equations, then you look at the intersection point. Okay, so it looks like this is the intersection point over here. They intersect here. The x coordinate will be what? 2, right? Y coordinate is 1. Okay, so that's the intersection point. Okay. Now, step B over here is to find the intersection point, which we found that over here, which is 2, 1. This is the So this is the x value and this is the y value. Okay. Now to make sure I got this, so this is supposed to be the solution for the system of two equations. Now, but to make sure that I got this right, I can check. So I check this by substituting them into the original equations. So this is the first equation, that's the second equation. I'm going to substitute x to be 2, y to be 1 into these two equations and see if they satisfy. So over here, I will have 2, x equal to 2, and then y here it is 1. Well, indeed, that's equal to 4, right? So equal to the right side. So that's check. Now, substitute x to be 2, y to be 1 over here, and see if this equation is true or not. 2 times x is 2, y is 1. Okay. Now, indeed, that's equal to 3. Okay, so that's check. This point satisfy both equations. So when I substitute x to be 2, y to be 1, the left side equal to right side for both equations. So they are satisfied. So we conclude that the solution for this system of two equation will be this 2, 1. Okay, so you write it this way, like a point. So x come first and y come next in alphabet order. Okay. Okay, so that's how we solve by graphing. Okay, so you graph them and you find the intersection point, and you can substitute that the x and y coordinate of that intersection point into the two original equation to see if they are satisfied. If yes, then indeed that's the solution. Okay. Okay, the next one I would like to let you try this one. Okay, I'm gonna give you guys about 3 minutes to try on this. Okay, can you guys try to find the solution by graphing them? Okay, go ahead. I'm gonna pause the recording. Okay, so what did you guys find? What's the solution? Are there any solutions? Okay, you trying to write on it? It's okay to write on my screen if you want. Oh, and you're trying to write on it, right? Okay. Nice. Let's see if you can do it. Let's see what happens. Okay, that's nice. Okay, very nice.
I think they're parallel, right?
Yeah, they're parallel. Yes. Oh, Andrew, you did a good job. So straight too. Nice. You annotated very nice. That's very nice. Okay. Okay, let's do it together then. Okay. All right. So what happened here is, so we try to first isolate this y here first. Okay. So put it in the intercept form. So if I put it that way, okay. So I can isolate this 3y. Okay, 3y here is equal to negative 2x plus 6. To isolate the y, we will divide both sides by 3. Okay? And then this will get y is equal to negative 2 over 3x plus 2. That's the first equation. For the second one, I first isolate 6y. So 6y is equal to negative 4x plus 24. And then I divide both sides by 6. Now notice that when you divide both sides by 6, this 4 and 6 here, 4 over 6 reduced to 2 over 3. So we get y is equal to negative 2 over 3 times x, and then plus 24 divided by 6 is 4. So we have this. Okay. Okay. Now I have this two equation. Okay. Now what do we see? You see that they are, okay. Now you see the slope. Okay. The slope over here is negative 2 over 3. The slope over here is negative 2 over 3. They have the same slope, which means that the two lines are parallel. So you got it right. So they are parallel, right? So they are parallel. So with the same slope, which is negative 2 over 3. You can think about this as a rise. So you're going to go down 2, and then run here is positive 3, and you go to the right side 3. So over here, I'm going to locate the y-intercept. So the 2 over here. So locate that. And then from the y-intercept point, I'm going to go down 2, go to the right 3. So down 2, right 3. So you got it, okay? So down 2, right 3 will be this point right here. Okay, so down 2, right 3. Okay, so got this point. Okay, so you're trying to annotate that. So that was good. So it's really hard on your part how to do it, you know. Let me see if I can do it. Okay, that's good. Okay, so that's for the first one. Okay, now the second one here, the y-intercept here is positive 4. So on the y-axis, locate 4. And then again, the slope is negative 2 over 3. So down 2 to the right 3. So we're going to go down 2 and then to the right 3. We end up at this point. Okay. And then we join. Okay. That's good. Okay. So we have this. And you see that they are parallel. Okay. That's good. So when two lines are parallel in the two-dimensional plane, they don't intersect, right? Okay. They don't intersect. So there's no intersection. So there's no intersection point, okay? So, but the intersection point corresponds to the solution of the system. So if I don't have intersection point, I will have no solution, right? Okay. So no solution. Now, a fancy way to write the solution set will be, do you guys remember? What's the fancy notation for the solution set is empty? What's the symbol? It's an empty set symbol, which is a 0 with a slash. It's like an empty basket. So that's the empty set. Okay. So the answer over here will be You can put down no solution, or you can put down the solution set will be the empty set. This one over here. Question? Now, suppose this is an in-class test. If I ask you to solve by graphing, you still graph both of them, okay? And then you write down the answer here, no solution, or solution set, you put down this empty set, okay? Any question? Okay. Now let's try number 3, this one. The first one is already in the slope-intercept form. So now what about the second one? Let's put that in slope-intercept form. So y here, 4y is isolated. So we're going to divide both sides by 4. So then we can isolate the y. Okay. So when we do that, this becomes y equal to 2 over 4 is the same as 1/2. So we reduce that to 1/2. 1/2 x plus 8 over 4 is 2. So plus 2. Okay.
I'm sorry, it's not a minus 1 over 2x? No?
Minus 1 over 2x? No. Because what happened over here? You divide both sides by 4, right? So 4y divided by 4 is y. So you have this y over here.
Yes.
And then 2 over 4 over here is 1/2. So there's no minus sign over here.
Okay.
Yeah. Because this equation over here is the same as 4y equal to 2x plus 8. Agree? Right? So I'm just putting the 4y on this side and putting this on the other side. Now, when you divide both sides by 4, you see that there's no minus sign over here. This is 2 over 4, which is 1/2. So positive 1/2 for the coefficient of x right there. Okay? Does that answer your question? All right. Now we're going to take a look at these two equations. Okay? This equation, they are the same equation, isn't it? Right? So because this one and this one, they are the same equation, the graph of both of them will be the same line. Okay? So how do I graph it? So I locate the y-intercept point, which is 2. And then because the slope is 1 over 2, so I go up 1 to the right 2 to get another point, this point. And then I graph it. Okay? And this will be for equation 1 and also equation 2. If I label this equation 1, this is equation 1, and this is equation 2. So both of them have this graph right here. Okay. Now, remember the intersection point correspond to the solution. So what are the intersection point of the two lines? Intersection point are the points that are in both. Okay, it's on the first line and also on the second line. Well, because they are the same line, then all points on this line are intersection point, right? Okay. So, see, every point on this line will satisfy the first equation and the second equation because they are the same equation. Okay. So all points on this line are intersection point and they are the solutions. Okay. So how should I write the solution set?
All real numbers?
Uh,
Infinity to infinity?
That's the tricky part, right? So it's not all real number. For example, if I pick this point, 0, 0, do you think 0, 0 is going to satisfy this equation?
No.
If I put 0 here and 0 here, no, right? It's not going to satisfy. So it's not all real number. Okay. So what are the solutions? The solution will be all points on this line. So only those points on this line will satisfy this equation, right? Okay. So the solution set over here we'll write down will be all points on this line. So this is in words. So you write down. So all points on this line will be the solution set will consist of all points on this line over here. Another way, instead of putting this equation, you can also put down the other equation, which is this equation here, because this equation is equivalent to this equation. These two are equivalent. So you can either put this one or this one. Okay. Now that's in Word. And if you put it in a math notation, so I'm going to teach you the notation. Okay. So remember the set notation. The set notation is a pair of curly braces. Remember that stands for set. So a pair of curly braces, it's kind of like a basket to put things in. Okay. And then the solution set consists of all points. Okay. For points, we have the x and y coordinate. So we write it down x comma y. Okay. So those for those points. Okay. But not all point. For example, if I have this point here, it's not going to be an intersection point. It's not a solution. 0, 0 is not a solution, right? So you have to put down the condition for membership over here. So you put a bar over here. You say, not everybody can enter this club. Okay. So it's like, okay, what kind of point? Okay. So those points will be on this line. Only those points on this line will be solutions. Okay. So you put down this equation over here. Okay. That's a condition for the membership to this solution. Okay. So or you can put down this one. Okay. Either this one or this one. Okay. They're equivalent. So what does this, how do we read this? Okay. This read as, so the solution set will be all points, x comma y. And then the bar here, you read that as such that. So that read as such that y equal to 1/2 x plus 2. Okay. So let me write that down for you. Okay. So the way that we read this is, we read this way. So the solution set will be the set of all points, x comma y, such that y equal to 1/2 x plus 2. Okay, so all points such that y equal to this. Okay, so that's that for all points on this line right here. Okay, how many points are on this line? Can someone tell me? How many points? This one, this one, this one, this one, this one. Those are all different points on this line. In fact, there's infinitely many points, right? And it extends forever. The coordinate for them doesn't have to be, don't have to be a whole number. It could be fractions or can be any real number. Okay, the coordinate for them. Okay, but those points have to satisfy this equation. Okay, so it will be on this line right here. The point has to be on this line. Okay, and we have infinite many points. So this system of two equation actually have infinite many solutions because I have infinite many points over here. And each one of them is an intersection point for both this one and this one because they are the same line. Okay? Okay, now I'm going to summarize it. Okay. Any question before we move on? Okay. Now let's summarize what we found. Okay. So far we have 3 cases. So the 2 lines here intersect at 1 point. Okay. And the second case, the 2 lines are parallel. And the last case, the 2 lines are the same line. Okay. Now this one here, when you graph it, you have only one intersection point. And intersection point correspond to the solution. So we have one solution. Okay, x comma y. Okay, so one solution. So this coordinate pair is called one solution of the system. Okay. Now what about this?
No solution?
You got it, okay? So no intersection point, then no solution. You got it. Good job, okay? So no solution because no intersection point, okay? Now what about this one over here? They have infinite many intersection points. Each point on this is an intersection point because these two are the same line, right? So we have infinite many solutions. So infinite many solutions. I use this to stand for whatever word above. I just have the same word as the above. Okay, so infinite many solutions. Okay, now I'm going to teach you a couple fancy words in here in math. So when you have no solution, when the system has no solution, we call that system of two equation. Okay, what do you mean system of two equation? So system of the equations. Remember the system of the equations are, you can have the first equation and then you can have the second equation, right? It's called a system. This is called a system of two equation right here. So you put a braces here that this two equation consists of a system of two equation. Okay. Now, if we have no solution, and then we will say the system here is inconsistent. Okay. No solution. We say this system here is inconsistent. I'm trying to draw over to see it will work. Oh, yeah, it worked now. So when the two lines are parallel, that we have no solution, and we say the system of the two equation here is inconsistent. So no solution, the system is inconsistent. Okay. Now opposite with inconsistent is what? Consistent, right? So then this one over here will be consistent. The other two, because they have solution. So consistent. So the other two, the system are consistent. Now what about the another fancy word right here? Is this? Okay. Have you guys filed your income tax yet? Now, if you file the income tax, in the same family, husband and wife, they can claim each other as dependent, right? In the same family, okay? So over here, you see that the two lines are the same, okay? And then we'll call the two equations dependent, okay? Okay. So the last case here, when the two lines are the same, okay? So we call the two equation, okay? The two equation will be, they are dependent, okay? They're the same line, dependent. Opposite with dependent will be independent. So these two will be independent because they are not the same line. So we write down independent. So dependent when the two lines are the same. And independent equations when the two lines are not the same. Okay, so there's two. Question? And we're done with today. So sweet. Sounds really yummy. I wish we can. Okay, that